This is part 2 of the video series on chair conformations. In this one, we're going to go through how to draw a chair conformation given a skeletal structure. So in step 1, we're first going to look at our skeletal structure, which is shown here, and fill in all of the missing hydrogens on carbons that have substituents. So here we have 3 different atoms that have substituents. Here we have this hydroxyl group, so we're going to add in a dashed hydrogen there. This chlorine carbon also has a dashed hydrogen here. And then we have a wedged hydrogen next to this bromine here. All right, next what we're going to do is take our structure that we have from step 1, and then we're going to draw in an empty chair. And so again, to do that, we first draw in those 2 parallel lines that are tilted to the right, and then we fill in those internal bonds. And whenever our lines are tilted to the right, that longer bond, or the one that I just highlighted in red, should be, that top one should be tilted towards the right. All right, for this, again, most of this is just memorizing that structure, and then once you have it down, you should just be able to draw out that empty structure. All right, we also in this step want to label carbon 1. And so for this, it doesn't really matter which carbons you choose, as long as all of the steps that you follow align with that choice. So for this, let's just choose this top carbon right here as carbon 1, and make the corresponding carbon in the chair structure be that top right carbon in the chair structure. And again, it does not matter which carbon you choose to be your carbon 1. There's no right or wrong place to start. You just have to make sure that you fill in the groups correctly based off of your choice. All right, all right, so we have carbon 1 here, carbon 1 here. Next, what we want to do is now we want to fill in our substituents. And so for this, we have to make sure that the wedge and dash line up with the chair's representation. So a wedge indicates that the group is facing towards us, which means it's coming above that flat. If we imagine that chair, it's coming above the chair. And a dash or dashed group represents it's below the chair. And so for our first chlorine group right here, and I'm going to use the structure up here to fill those in right there. But we see that we have that chlorine is a wedge. And so that means that for this carbon right here, which has these 2 possible bonds, that hydrogen has to go above the chair. So it has to go up. And so we can see that this bond right here is going up, and it corresponds to that wedge group. We also have that dash hydrogen attached to that carbon. And so we can see that since it's dash, it's going to be going down. And so HA is going to be tilted down here. So we can see that the dash corresponds to a slight tilt down. It's not fully vertical, but it is slightly tilted down. All right, next we can do that bromine. So we have a dashed bromine and a wedged hydrogen B. And so to fill in that next group, which is now step 4, we move clockwise over 1 carbon. So in that first structure, we're on carbon 1 in the top right. Now we're going to be on carbon 2, which is going to be that bottom right one. We're moving over 1 on each structure. And so for this, we have to still follow the same rules that a wedge is above the chair, a dash is below. And so what we can see now is that that bromine is dashed, and so it has to be facing down. And so out of the 2 possible lines that that carbon can have, we have that the bromine is tilted down, and HB, which is wedged, is going to be slightly tilted up. And so we can see now that our 2 dash groups are both facing down, and our 2 wedge groups are both tilted up. All right, next we're going to keep going in a circle because we have 1 more substituent to add in. So carbons 3, 4, and 5 only have hydrogens, so you might have to, for your class, draw in the 2 lines and put hydrogens. It doesn't really matter, they're both hydrogens, so they're going to look the same. But once we get to carbon 6 here, you can see that we now have another substituent, and so now we have to determine how to place those. So I'll draw in hydrogen C here. And then in our chair structure, we're now on to this carbon in the middle right here. And so first we're going to draw in the two lines that correspond to that carbon, which are going to be one that's kind of tilted a little bit up towards that shorter bond, and then one that's going down towards the middle of the chair. And so from here, we can see that our OH group is wedged, and so that wants to be tilted up. And our HC is dashed, and so that wants to go on that line that projects downward. And so similar to the other ones, we can see that the wedge group, which is that OH, is tilted up. And that green one, or HC, represents dash group and is tilted down. And tilt is not the same thing as being axial or equatorial. That's two different things. We're just kind of using the lines to help represent whether it's dashed or wedged. All right, and so again, the main thing is we just want to make sure that those dashed and wedged groups correspond to the correct bonds in the empty chair conformation. All right, so that wraps up how to draw that initial structure. In the next video, we'll talk about how to do the chair flip and then how to determine which chair conformation is the most stable.